Hello everyone, Raheem here, welcoming you to Toppers Edge. Today, we're starting a really important lesson for Class 10 students. We're going to quickly go over chemical reactions and equations. Think of this as a super helpful guide to understand all the basics. This material was made for you to easily learn and remember the important stuff. We know that studying can sometimes be tough, but don't worry, we are here to help. We will explain everything step by step. This revision is going to make sure you are all ready and confident for your tests. So get ready to learn and let's get started on understanding what chemical reactions and equations are all about. Check description for notes. Okay, let's talk about what a chemical reaction really is. It sounds fancy, but it's something we see every day. A chemical reaction is when one thing changes into another, different thing. Like, when iron gets rusty, it's not just iron anymore, it's turned into something new. That's a chemical reaction. Or when milk turns into yogurt, it's another example. Milk changes and becomes something new, something different. That change is what we call a chemical reaction. Now, how do we write these changes down? We use chemical equations. These are like short ways to write down what happens. We use letters and symbols instead of writing long sentences. Like we see here, A plus B gives you C plus D. This means two things, A and B, come together and make two new things. C and D. A and B are called reactants, because they are what we start with. C and D are called products, because they are what we get at the end. There's an example too. Mg plus O2 gives you MgO. This means magnesium, Mg, and oxygen, O2. Combine and make magnesium oxide, magnesium oxide. It's just a simple way to write what happens when these things come together. Now, we can make our chemical equations even better by adding more information. We can say if something is solid, liquid, or gas. We use letters in brackets for that. S for solid, L for liquid, and G for gas. We can also say if something is mixed in water, and we call that aqueous, AQ. If we are using an acid, we can say if it's strong, concentrated, or conc, or weak, dilute, or dill. We also show if heat is given out or taken in during the reaction. If heat is given out, we write products plus heat. If heat is taken in, we write reactants plus heat. And we can add the things we need for the reaction to happen, like temperature, pressure, a catalyst, something that helps the reaction, or even sunlight. There's an example here. Zn plus 2HCl gives you zinc chloride, AQ, plus H2 plus heat. So, this means zinc, solid, reacts with hydrochloric acid, aqueous, concentrated, and makes zinc chloride, aqueous, and hydrogen gas, and also gives out heat. There are some really important words we need to know when we talk about chemical reactions. One is precipitate. A precipitate is a solid thing that forms in a liquid during a reaction and then falls to the bottom. It's like when you mix two liquids and something solid appears. Another is exothermic reactions. These are reactions that give out heat. You can sometimes feel it getting hot. Then there are endothermic reactions. These are reactions that take in heat, so they can make things feel cold. And lastly, we have catalyst. A catalyst is something that helps a reaction happen faster, or with less heat or pressure. But the catalyst doesn't get used up in the reaction. It's still there at the end. An example is iron used in making ammonia. It helps, but it doesn't get used up. How can we tell if a chemical reaction has happened? There are some things to look for. First, there might be a change in color, like something going from blue to green. Second, there could be a change in temperature. Things might get hot or cold. Third, the state might change, like a gas turning into a liquid. Fourth, you might see an evolution of gas, which means bubbles are formed. Fifth, you could see the formation of precipitate, a solid forming in a liquid. Then, we have endothermic reactions where heat is taken in, like in photosynthesis. And exothermic reactions where heat is given out, like when calcium oxide mixes with water, or during digestion and respiration. There are examples for each of these given here, so make sure you read them carefully and understand what each change looks like. Now, let's talk about balanced chemical equations. A balanced equation is when the number of each type of atom is the same on both sides of the equation. This is important because of the law of conservation of mass. This law says that mass can't be made or destroyed in a chemical reaction. So, the mass of what we start with, reactants, must be the same as the mass of what we end up with, products. That's why we need to balance the equations. There are some examples here, and it's really important to practice balancing these. It's something you'll definitely need for your exams. So try to work out the answers yourself, and make sure you understand how to make sure both sides of the equation have the same number of each atom. There are different types of chemical reactions. First, we have combination reactions. This is when two or more things come together to make one new thing. Think of A plus B becoming AB, like calcium oxide and water making calcium hydroxide. We also have a carbon dioxide test. This is when we bubble carbon dioxide gas through lime water to check if it's there. Then we have decomposition reactions. This is when one thing breaks down into two or more things. Think of AB becoming A plus B like calcium carbonate breaking down into calcium oxide and carbon dioxide, or iron sulfate breaking down into other things. We can break down decomposition reactions further. There's thermal decomposition, which happens when we heat something, like heating calcium carbonate. Then there's photolytic decomposition, which happens when we shine light on something, like silver bromide in old cameras. And there's electrolytic decomposition, which happens when we pass electricity through something, like water. There's also a hydrogen test, where hydrogen gas makes a popping sound when you light it, while oxygen makes a flame burn brighter. This page has a picture of electrolytic decomposition of water. It's like we talked about before. You can see the setup with the battery, the wires, the water, and the tubes. You'll see that we collect hydrogen and oxygen gases in separate tubes. It's a good idea to look at this picture carefully and understand how everything is connected and where each gas goes. It will help you remember what happens in this process. Now, let's talk about displacement reactions. This is when one thing pushes out another thing from a compound. There's single displacement, where one element pushes out another element from a compound, like zinc pushing out copper from copper sulfate. Then there's double displacement, where two compounds switch partners, like sodium sulfate and barium chloride switching to make barium sulfate and sodium chloride. Here we have the reactivity series. This is a list of metals from the most reactive to the least reactive. Potassium is at the top and most reactive, and gold is at the bottom and least reactive. It's important to know this list because it helps us understand which metals can push out others in a reaction. There's a secret trick to remember this list here too. These are more examples of reactions. We see magnesium burning, lead nitrate reacting, zinc with sulfuric acid, calcium oxide with water, and iron sulfate decomposing. Each reaction has something special that happens, like color changes, gas bubbles, or heat. Make sure to note these changes, as they help you know what's going on. Alright, more reaction examples on this page. We're looking at what happens in a few different chemical changes. First, when we heat lead nitrate, it breaks down and makes lead oxide, nitrogen dioxide, and oxygen. That nitrogen dioxide gas you'll see? It's a brown gas. And the lead oxide left behind, it changes color depending on how hot or cold it is. Next, silver chloride. If you leave this in sunlight, it changes from white to gray. It makes silver and chlorine gas. Then we have iron reacting with copper sulfate. The copper sulfate is a deep blue color. When iron goes in, the blue color fades to light green, because it's making iron sulfate now. And you'll also see a red-brown layer form on the iron. That's the copper coming out. Also, sodium sulfate and barium chloride when mixed together make a solid white stuff, which we call a precipitate, barium sulfate, and sodium chloride. Lastly, copper and oxygen combine when heated to form a black substance called copper oxide. If we pass hydrogen gas over this copper oxide, it will make copper again. It's like undoing the reaction. On this page, we're talking about redox reactions. Redox is short for reduction and oxidation. Oxidation is when something gains oxygen or loses hydrogen. Reduction is the opposite, when something loses oxygen or gains hydrogen. There's an example here with manganese dioxide and hydrochloric acid. Some things get oxidized, meaning they gain oxygen or lose hydrogen, and some things get reduced, meaning they lose oxygen or gain hydrogen. You'll also see zinc oxide reacting with carbon. In this case, zinc oxide loses oxygen to become zinc, so it is reduced, while carbon gains oxygen to become carbon monoxide, so it is oxidized. An oxidizing agent is something that helps oxidation happen, and it gets reduced itself. A reducing agent helps reduction happen and gets oxidized itself. So they're like helper molecules for these reactions, but they change themselves in the process, too. Here we look at how oxidation affects our daily life. One big thing is corrosion. Corrosion is when metals get damaged by reactions with things around them, like water or air. Rust on iron is a big example. Silver can get dark, and copper can get a green coating. How do we stop this? Well, we can put protective layers on the metals, like paint, to stop them from touching the air and water directly. There's also a reaction with silver and hydrogen sulfide in the air, making silver sulfide, which is black. And another reaction with copper, water, carbon dioxide and oxygen that makes copper carbonate and copper hydroxide, which is the green coating we sometimes see on copper things. Another thing oxidation affects in daily life is rancidity. This is what happens when fats and oils in our food go bad. They start to smell and taste funny. Butter can spoil, cooking oil gets old, and chips can go stale. This is all because of oxidation. How do we stop this? We can add things called antioxidants to the food, or keep the food in containers that stop air from getting in. And keeping food in the fridge can also slow down this process. It's all about stopping or slowing down the oxidation that makes our food go bad. As Prashant says here, fodenge, which basically means we will crack it or ace it, or we will understand this. Okay, everyone, we're almost at the end. This page has a question for you to try. We have a chemical equation, but we need to fill in some missing numbers to make it balanced. Here's the question in words. We have sodium carbonate reacting with some number of hydrochloric acid molecules, making sodium chloride, carbon dioxide, and some number of water molecules. You need to figure out how many hydrochloric acid molecules and how many water molecules there are. So, what we need to know is, if you have one sodium carbonate reacting, what numbers go in the place of X before hydrochloric acid and Y before water to balance the equation? The options are 1 and 2, or 2 and 2, or 2 and 1. So, figure out what numbers, X, and Y, are to balance the equation. Once you have your answer, put your answer in the comment section below. Tell us what you think the right numbers are, and we'll see how many of you get it right. And last but not least, another question for you on this final page. This time, it's about sodium reacting with water. We know that when sodium reacts with water, it makes sodium hydroxide and hydrogen gas. But the question is, which of the equations is the correct, balanced one? There are 4 options given to you. All the options list sodium, water, sodium hydroxide, and hydrogen, but the numbers in front are different. You need to choose the one that has the same number of each type of atom on both sides. So, you have a few options. Option A has sodium and twice water making twice sodium hydroxide and twice hydrogen. Option B has twice sodium and twice water making twice sodium hydroxide and 1 hydrogen. Option C has twice sodium and twice water making twice sodium hydroxide and twice hydrogen. And option D has twice sodium and just 1 water making twice sodium hydroxide and twice hydrogen. You need to pick the correct one that has the right balance. Once you think you know the answer, please write it in the comment section below. Let us know which option, A, B, C, or D, you think is correct. We're excited to see how you all do, so don't forget to post your answer. Thank you for watching Toppers Edge. We hope this rapid revision guide on chemical reactions and equations has been beneficial for your Class 10 preparation. Remember to practice balancing equations, understand the different types of reactions, and review the concepts of oxidation and reduction. With diligent study and consistent practice, you'll surely excel in your exams. Best of luck with your studies.